Good evening, madam. I think, madam, set it start, madam.
Sir, hello, good.
मैडम आपका वॉइस ब्रेक हो रहा है.
Sir, am I audible, sir?
Yes, ma'am, but your voice has this one echo issue. Madam. I think there are two devices working in the same room. I think.
Okay.
One has to be off, ma'am.
I think the devices.
Still, madam, we have to send power.
Hello.
Madam, still your voice is there's echo issue.
Madam, have you logged in from two different devices? मैडम दो डिवाइस से लॉग इन किया है तो एक आप लॉग आउट कर लीजिए.
Okay, ठीक है.
I think only one device is left. Madam, can we start? Once check your audio and video. Sharita madam.
मैडम ने ज्वाइन तो कर ली मगर सर इसका बच्चे को दो.
Hello ma'am. You just ask her to unmute. Roman.
मैं कर दूं.
Yeah, madam already switch on video. Sharita ma'am, if you have joined.
Now is it okay, sir?
Yeah, it is okay, perfectly fine.
Okay, sir.
Okay, so we can start the meeting.
Yes, sir.
Okay, so friends, today's evening I welcome Dr. P. Srilata. She is a renowned personality, especially in the work of conservation agriculture in rice maize cropping system. She not only have worked on the research farm, but she has made her footprints at the farmers field, and that had led to adoption of the zero tillage maize cultivation on around 1.5 lakh hectare acreage. So, Madam is an expert on the, especially on the zero tillage maize and all other related technologies which can be. So, I request Madam to kindly share your presentation, and now floor is yours for next 30 to 40 minutes. Please.
Okay. Okay, sir. I will share my presentation. Sir, is it visible, sir?
Madam, again, echo issue is there. What you can do? Two devices.
Sir, let her log out from one of the devices. She has two logins.
Madam,
Yes,
from
all-
where you are sharing from other device? That
No.
moment, what you can do? The other one you can put in the waiting room. That Roman?
इनके नाम पे मैडम के नाम पे एक ही है शायद।
दूसरा एक डिवाइस और है। मैम आप बोलिए।
Sir,
हेलो।
hello.
Yes, madam. I think you have joined with one another name also.
Okay, I will close
Just-
this one, sir.
You close that one.
ओके ओके एक पलक का
So meanwhile, you take the second presentation, sir. So I will set up this one.
Okay, no issue. So we can invite Dr. AK Singh, sir. So Dr. AK Singh ji have led the Maize program from for around 17 years for national level, and sir is spearheaded especially the precision nutrient management and conservation agriculture based ecosystem development in India. And now Dr. AK Singh sir is in posted at CSSRI Karnar. I request Dr. AK Singh sir to kindly share your rich experience, and thank you very much for accepting the request to deliver your lecture. AK Singh sir, now floor is yours. You may start your presentation now.
Now is it visible?
Yes, sir, it's visible. Just make it in slide share mode.
नहीं हुआ क्या?
नहीं हुआ सर। ये ऊपर
स्लाइड
जो
मोड में नहीं है।
F5 दबा दीजिए सर आपके कंप्यूटर से। प्रेस F5।
हुआ नहीं?
No sir, no, still it's not there. Or you just press that slide share button. ना?
वही तो कर रहा हूँ यार।
F5, just press F5 button.
F5 को दबा दिया।
F5 से नहीं हो रहा।
ओ ये शेयर यहाँ से कर रहा हूँ।
आपके कंप्यूटर पे पूरा हो रहा है?
हाँ
नहीं यहाँ से नहीं सर। आपके कंप्यूटर पे पूरा आ रहा है?
हाँ
पूरा फुल आ रहा। यहाँ पे करिए सर। हाँ ये वाला क्लिक है। हाँ नाउ इट्स परफेक्ट सर, यू कैन गो अहेड।
okay. So good evening to all of you. Thank you Dr. SL and my dear colleagues and fellow scientists and stakeholders. I've been assigned for delivering a lecture on conservation agriculture practices, residue management for improving crop productivity. You know, the most important challenge is population, ever increasing population, and right now we have overtaken China and become most populous country in the world. And if you see, the population density is almost in the range of 500 to 1,000 persons per square kilometer. So, and even in neighboring Bangladesh, it is more than 1,000. If you see the global extent and degree of land degradation, mostly natural resources, degradation, land, water, and biodiversity, they are highly stressed. And our, not only India, but most of the African countries, India, Southeast Asia, all are very hot spot for future climate vulnerability. And this year already effect of El Nino has taken place, and lot of erratic monsoon has already, and already experts are predicting that almost 20 to 30% less rainfall will occur in this year. If you see the soil carbon status, our country mostly comes under tropical climate where temperatures are very high. So in general, the burning of carbon is very high. And if you see the in our country, it ranges almost in between 10 to 30 this tons per hectare. And if you see global water scarcity, because next decade, all wars which are likely to be happen for sharing of water, all countries are facing. The glaciers are melting, and this because of the climate change, the water availability is very limited. So almost 1.4 to 4 billion people are facing water scarcity from 1 to 12 months. Around 4 billion people are facing water scarcity from 1 month period in a year, and around 500 million people are facing water scarcity across 12 months. So it means water is very scarce. And if you see, by 2040, our country is already in high stress zone, and in otherwise only one extremely high is left. So otherwise we are very vulnerable. Lot of over exploitation of water is taking place, and one of the major reason is the monocropping system. So these are the challenges. If you see the climate change and its effect on cereals in our country, mainly 3 crops are there: rice, wheat, and maize. If you see in the changes in rice are not much severe because it depends on water. So if water is available, rice can be grown. But the effect of this changes in the climate will have maximum effect on wheat and maize crop. If you see its adaptation, then you can find that in rice, again, the adaptation is very high. But in case of wheat, it is very less. But maize is also responsive for adaptation. Now, if you see the yield gaps, there are 2 types of yield gaps: management yield gaps and potential yield gaps. So in case of both all the 3 crops, rice, wheat, and maize is most potential crop for responding to management yield gap as well as potential yield gap. That means there is a lot of potential for maize as compared to rice and wheat. Now, if you see what is the answer? Because already, because of the monoculture and continuous tillage operations and the burning of the residue, we are plowing, we are removing all the organic matter, we are not adding any FYM, monoculture is taking place. So what is the answer? Its answer is conservation agriculture. And in conservation agriculture, if you see, it's 3 basic principles. First, minimum soil disturbance, that means zero tillage. With second is always keeping permanent organic soil cover. That means in our country, 100% residue retention is not possible because of the bovine pressure. Animal population is very high, but at least 1/3 of the residue we can retain. And third and most important is diversified crop rotations. That means monoculture in whole Indo-Gangetic plain, rice, wheat is cropping system is taken up. So we have to diversify. We have to include this maize. Then we have to include legumes in the form of moong or soybean. So what are the benefits of this conservation agriculture? For sustainability, that means because previously when our agriculture was dependent on animals, then we were recycling or farmyard manure. But because of mechanizations, now availability of FYM is not there. So what is the answer? Answer is keeping residue. So if we are keeping residue, then it recycle nutrients. So sustainability of our cropping system can happen. Enhanced biodiversity, then carbon sequestration, because carbon is the most important thing. You know that earthworm population and all the soil physical chemical properties, they are influenced by carbon. So carbon sequestration is very important, not only for improving the soil fertility or soil productivity, but at the same time also to manage our biodiversity. Then labor saving, because in conservation agriculture we are doing zero tillage or minimum tillage, so it is less labor requiring. Soils are becoming very good, not only physical but chemical properties are also increased. Then when sufficient amount of nutrient is continuously available, then yields are also increased. Then cost of cultivation is also reduced. So it is adopted throughout the world, around 205 million hectare area, almost 12.5% in the world. And India is also having 3.5 million hectare area. So India made very significant progress on CA machinery prototype development. Since 98, we have done a lot of modifications, particularly initially Pandagar University has developed zero-till machines, but now lot of improvement has taken place. And you can see these are the initial seeding machinery. Now we are having very good happy seeder, turbo happy seeders, which are very effective because conservation agriculture depend on the good quality of machinery. So in the form of happy seeder, we are having, I think most of you know who are working at farmers field, they must be knowing that how important or how efficient is happy seeder in tackling this residue problem. Then on a small scale holder also, these small machinery can, because all farm holdings are not large. So for small holdings also, this kind of small machinery can be utilized. Now you can see this new knife roller for mulching and seeding. That means simultaneously this mulching is done by in front by this tractor, and this sowing is also done. Now you see this now combined harvesters have come up in some modifications have taken place, and almost all crops can be harvested with the help of combine. Now this relay cropping is also can be done by simply modifying tractors. You can see this in relay cropping, that means in standing crop of wheat, this moong bean can be sown. So this is how this tractor can be modified, and you can see this moong bean is generating, because moong crop in theoretical it requires 55 to 60 days, but in practically it takes at least 65 to 70 days. So if we wait for harvesting of wheat, then this moong yields are very much affected. Then how we can take, because most vulnerable crop is wheat, because of when the conventional rice, after growing rice, this puddled rice, if we go for this 25 to 30 days for preparation of feed, then this moong crop wheat crop is facing terminal heat because of the change in the climate. So in direct seeded rice or zero till wheat moong bean or zero till soybean wheat moong bean, moong can be very much easily fitted, and at the same time higher yields of wheat can be taken. Water saving is there, almost 28 to 28% water saving. Then global warming potential is also lowered down with the help of this conservation agriculture practices. And at the same time, when we are retaining residue, then less weed problem is occurring. You can see the superb rice wheat system. Now, in direct seeded rice, followed by zero till wheat, followed by zero till mung bean. Then transplanted rice also, if we follow zero till wheat, then mung bean. Then, so this is how this crop cycle is taking place. And by this way, we can save water, we can increase partial factor productivity for nitrogen and phosphorus, non-renewable energy can be reduced, and by this way, ultimately, we can increase yield and net returns. These are the views of some of the maize-based cropping system. Then you can see diversified opportunities in which mustard and wheat crop can be taken after maize, wheat, mustard, mung bean, or maize, wheat, mung bean. So what are the how we can say this is the cropping efficient system? It is advancing wheat plantation, because just after harvesting of rice or maize, we can directly go for sowing of the wheat with the help of happy seeder. So increased wheat duration. Then water requirement is also less, because residue cover is there. So because of the residue cover, this less water requirement. Then we know that this residue is very important for maintaining temperature, because whatsoever residue we are retaining, it is the bad conductor of heat. So beneath residue, this temperature effect are minimal. So the terminal heat stress is also less. And when continuously proper moisture, less weeds are, and continuously nutrient availability is there, it enhances wheat yield. So, and at the same time, just after harvesting of wheat or relay cropping, this mung bean can be planted. So, 3 crops can be taken with the lesser amount of water as compared to rice alone. So, it is a very beneficial system. Then, maize, mustard, mung bean system is also very important, particularly in conservation agriculture. It advancing mustard planting, increase mustard duration, reduce aphid infestation, and it also enhances mustard yield and timely planting of third crop. So you can see, then at the same time, we have also witnessed that nowadays subsurface drainage are also coming up. So you can see, with the help of subsurface drainage, we can apply nutrient. And so with the fertigation, almost 25% saving of nitrogen in both maize and wheat is occurring. And at the same time, in case of rice, 20% nitrogen can be saved. And here, almost 100 to 150% more irrigation water productivity can be obtained in maize and wheat. And in case of rice, 10 to 30% productivity can be higher water productivity can be obtained. So these are the some of the findings where, with the help of this subsurface drainage, almost 25 to 30% nitrogen saving is there, and very high agronomic efficiency of almost 39% can be obtained. Now, the most important aspect in conservation agriculture is efficient management of wheat, because wheat problem, initial 2 to 3 years, wheat management is very important. So previously, when we are not having efficient post-emergence herbicides, but nowadays, lot of post-emergence herbicides are there. Wherever motha or cypress problem is there, halosulfuron is very effective. Otherwise, in rest of the conditions, tambotrin lodis or topramazone tincture is very effective. Then in DSR rice also, lot of these herbicides are available. Similarly, in case of wheat also, so we can easily control weeds problem, because initially, as I told you, initially when we start adopting conservation agriculture, then this problem we have to manage. Then, with the help of conservation agriculture, different soil parameters are very much affected. And we have seen, after completion of 3 years or after completion of 7 years, wherever permanent bed or zero tillage are measured or used as compared to conventional tillage, then this penetration resistance is reduced. Then, with the help of this conservation agriculture, it can increase yield by 21% and profit by 40%. Soil quality index are improved by almost 138%. Carbon stock is almost improved by 60%. And greenhouse gas emissions can be reduced by 55%, and residue burning can be eliminated. So a decade of conservation agriculture in intensive serious system on soil properties, as from the very beginning, I am telling you that when we are retaining the residue, then soil organic carbon can be increased by 1.83 fold. Infiltration rate is doubled. And one of the major reasons is that when organic carbon is maintained by keeping crop residue, then activity of earthworm is increased. And when earthworm activity is increased, they develop natural drainage. And by this way, infiltration, whenever you visit any CA field, you will find that even very high intensity after rains, you will not find a single drop of water on the soil surface. So soil compaction is reduced because natural drainage is done with the help of these roots as well as these earthworms. Soil bulk density is lower down. Conservation agriculture and its benefits, as I from the very beginning telling you that very high yields can be obtained, returns can be improved, then it improves soil physical, chemical as well as biological properties, and already it is adopted in more than 1 lakh hectare area in erstwhile Andhra Pradesh and Tamil Nadu. And this zero tillage is very much effective, particularly in Andhra Pradesh, where after harvesting of rice, farmers have very easily switched over to conservation agriculture practices. That means because they have narrowed the gap of this almost 20 to 25 days. So by this way, area increased in Rabi maize, crop intensification taking place, timely operations done, then saving of fuel, natural resources. So these are the then we have also found that wherever this residue retention is taking place, because this zero tillage was initially adopted at Patnagar University in 1970s, but it was failed. And one of the basic reasons was that they have not retained crop residue. So without residue, this conservation agriculture is not successful. So whenever crop residue is there, natural enemies are developed and FA can be managed. Then these are the some beneficial arthropods and earthworm count under CA-based maize practices. Then you can see the microbial population, bacteria, fungi, and acetomites, all are increased, whether it is rice-based system or maize-based systems. Then, as I told you, that water stagnation in conventional tillage, lot of water is stagnated because of the compaction, hard pile is created. But in zero tillage, natural drainage is developed by these roots as well as by the earthworm activity. So you will not find a single drop of water in conservation agriculture field. You can see in CT, CA as well as difference between CT and CA. Very good crop in CA you can see. Then the wheat seed bank study was also done. And it has been observed in CT, very high density of weeds as compared to zero tillage or permanent bed is taking place. That means weed seed bank are also can be controlled. Then earthworm and ant activity, as I told you, then ant burrows as well as earthworm activity is very high in CA fields. Then these are the different agroclimatic regions, and particularly in upper Indo-Gangetic plains, we can very easily propagate maize, wheat, mung bean, maize, mustard, mung bean, or rice wheat, or maize chickpea. Then, since I have seen Dr. Srilata is there, so she will deliver her lecture on crop residue management. So I will not cover it much, but at last I would like to say that at Ludhiana, we have conducted one CA experiment. In last 9 years, we have found that continuously when this CA, if you see, system yield was significantly better as compared to maize wheat without residue. or made with residue or without residue. And for last 2-3 years, we have started 100% residue retention because we have kept some dummy plots, and we have found that when we switched over to 100% residue retention, then in second year onwards, 25-30% nitrogen saving was there, and third or fourth year, almost 40 to 45% nitrogen can be saved. So the whatever government target are there, they can be very easily achieved by adopting conservation agriculture. So a little amount of residue stable is very much effective in conservation agriculture. So for success of CA, first we have to do chiseling or subsoiling so that hard pan can be breakdown, and then leveling of field can be done. And by this way, we can start adopting. So what are the way forward for enhancing CA adoption? Customize CA for various agroecologies and farm typology. Farmers participatory research. Farmers participation is very important. We should be done what we should do or what we should not do. Identification of domains by SWOT analysis. Then strengthening of input management tailored for CA. Then harnessing interaction effect of genotype into environment into management, and incentive or recognition to the farmers should be done who are adopting this. So this is all. Thank you very much. Thank you.
किसी का अगर सवाल है तो पूछ सकते हैं सर से. If anyone has a question, has question.
सर
गुड
मैंने
इवनिंग
मेंशन
सर.
बॉक्स में
मैं धनंजय तिवारी सर बिहार से बात कर रहा हूँ सर. सर
हाँ जी,
क्रॉप
हाँ जी,
रेसिड्यूज मैनेजमेंट की हम तो बात कर रहे हैं, लेकिन फार्मर लेवल पे इसको हम एग्जीक्यूट नहीं कर पा रहे हैं सर. एक्चुअल में देखता हूँ यहाँ क्रॉप रेसिड्यूज बर्निंग की भी मेजर इश्यूज है सर. तो इसको सर फार्मर्स को कैसे मोटिवेट किया जाए, या
देखिए सर,
कौन
ऐसा
से
है कि
सॉल्यूशन?
इसमें जो सबसे बड़ी प्रॉब्लम इशू है कि इसकी जो मशीनरी है ना, जो जैसे हैप्पी सीडर है, वो थोड़ा सा कॉस्टली है. तो हमें या तो कस्टम हायर बेसिस पर मतलब आजकल क्या है कि काफी सारे स्टूडेंट्स जो अपने ग्रेजुएशन करने के बाद में, इफ दे कैन अडॉप्ट, I mean by taking some kind of loan or that way, if they start providing this custom hire basis, then it can be successful. क्योंकि ये थोड़ा सा जो हैप्पी सीडर है थोड़ा सा कॉस्टली इक्विपमेंट है, और एवरी फार्मर कैन नॉट अफोर्ड इट. तो सबसे इंपॉर्टेंट है कि हमें मशीनरी और वीड मैनेजमेंट और थोड़ा सा उनको एक मोटिवेशन, उनको जो भी हमारे यहाँ जहाँ से लुधियाना में है या दिल्ली में है, जहाँ पर भी ये जो हमारा कंजर्वेशन एग्रीकल्चर का एक्सपेरिमेंट चल रहा है, वो उसको उनको दिखाएं, उनको वीडियो दिखाएं, then they will be definitely motivated, because residue is having almost 25% of nitrogen and phosphorus, almost 30% sulfur, and 75% of potassium, and all macronutrients are available with the residue. तो अब आने वाले टाइम में जब गवर्नमेंट की तरफ से क्योंकि आपने देखा होगा ईरान वार में हमारे पास फर्टिलाइजर की शॉर्टेज हो गई, तो ऐसी कंडीशन आ सकती है कभी भी कि हमें फर्टिलाइजर अवेलेबल नहीं हो. दिस इज द वेरी रेडी रेकनर कि हम फार्मर को मोटिवेट करें जिससे कि वो रेजिड्यू बर्निंग करने के बजाय क्रॉप में रिसाइकिल.
Sir, we'll take one more question. Sir, there is one question in the chat box, sir. How does conservation agriculture lessen disease pressure, especially stalk rot in maize?
क्या दोबारा बोले?
सर, कंजर्वेशन एग्रीकल्चर से सर डिजीज प्रेशर कैसे कम होता है, स्पेशली स्टॉक ग्रोथ इन मेज?
Actually, when conservation agriculture practices are followed, then I told you that the activity of earthworm, ants are increased. So good bacteria, because good bacteria, fungi, actinomycetes, as I have shown you in one of the slides, their activity is increased. When their activity is increased, then in all crops, two types of harmful bacteria or harmful disease pests are there, and beneficial. So the activity of beneficial, because of the increased availability of carbon is there. So because of that, the good bacteria, fungicide, they have increased. So because of that, disease as well as FA, all are reduced.
थैंक यू सो मच सर, आपने बहुत अच्छे से बताया सर। और मूविंग टू द नेक्स्ट प्रेजेंटेशन सर, मैडम आपका वो वॉइस वाला एक बार चेक कर लेते हैं मैडम।
Yes, sir. Check karo.
नाउ इट्स फाइन आई थिंक।
Shall I share, sir?
यस सर, यस सर, यस मैम। थैंक यू सो मच सर, AK सिंह सर, थैंक यू सो मच सर।
Thank you, thank you, thank you, thank you.
हाँ,
So is it visible, sir?
नोट येट मैडम, मैम इज विजिबल। स्लाइड मोड में कर दीजिए मैम, स्लाइड मोड, प्रेजेंटेशन मोड।
Is it okay, sir?
मैडम कैन
Is
यू,
it okay?
मैडम कैन यू पुट इन
Lata ma'am,
प्रेजेंटेशन?
yeah, now it is fine. Now it is
नाउ
fine.
इज फाइन मैम।
Okay, sir.
Yeah.
So,
Yeah.
so good evening to one and all. Yes, a principal scientist working at Professor Jayashankar, Telangana Agriculture University. So very good evening to all participants. Today I would like to talk on crop residue management, which is a sustainable approach for conservation agriculture. Now my earlier speaker, so my guru, Dr. AK Singh sir, now has presented elaborately on conservation agriculture. But just I want to speak on crop residue management, how it is nowadays is a need of the hour. Just I would like to present. And so here we can, why we have to think for crop residue management, we have to see, because we are residing on tropical and subtropical climate regions. So mostly which are characterized by high temperatures and intense solar radiation. And nowadays we are facing heavy and also erratic distribution of rainfall, which mainly leading to rapid organ matter mineralization and nutrient loss also. So with this, so most of the tropical soils are generally we'll face our Indian conditions are very light soils, that is axisols and alphisols. Alphysol kind of soils, which are very low in fertility and organic carbon. As we all know, these kind of soils are very less organic carbon, almost 0.5 to 1%. So nowadays, with this kind of situations, crop residue management or recycling of residue is an essential strategy for maintaining our soil productivity. And one more, not only this, in tropical farming systems, where multiple cropping systems are continuous cultivation with the high potential crops are evolving, like rice maize system or rice wheat system, and also in our these particularly in Andhra Pradesh, this rice maize system is almost in 3 more than 1 lakh hectares are under zero tillage conditions. And here also maize followed by maize, that maize based system is also very prevalent in these particularly in Andhra Pradesh, Telangana, Maharashtra, Karnataka areas. So with this continuous cultivation of monocropping, as well as this high input to use efficiency cropping systems also leads to rapid decline in soil organic carbon. So hence incorporating crop residues or retaining 1/3 or whatever it may be, 10% or 30% on the soil surface will definitely increase the soil carbon by 15 to 30%. So within a span of 3 to 5 years. So when this crop residue management, we all know this is a very crucial role in promoting agricultural sustainability. So particularly for safeguarding the environment and also enhancing rural livelihood. So once we see the scenario of crop residue generation, as you all know these statistics. So because major crop residue producers, China, Russia, and United States, Brazil, including India also. So in India, the scenario is almost 683 million tons of crop residues are produced in various crops annually. So particularly most of the 70% of the total crop residues account for with the cereal crops. We know that rice, wheat, maize, and millet crops. And among these cereal crops also rice only contributing alone 34%, and next come to the wheat. And in cotton is also one of the important commercial crop of our country. So it also generates almost 53 million tons of total residues. And so next we can see the pulses and oilseeds and sugarcane is also contributes the remaining fractions of these crop and residues. So once if this kind of huge quantities of residue generations, so we can definitely, we have to see how best we can manage these crop residues at farm level, or in especially in India and our most of the states, very small holdings are available with the farmers. Definitely we have to think it's how best we can manage these residues. So mostly residue generations varies significantly across the states, especially nowadays Punjab, Haryana, Uttar Pradesh are being the largest contributors for this residue management. So this almost all you are aware with this. What kind of residues will mostly will see field residues, as you all know. Stalks, stems, leaves, and roots. This kind of residues will generally available after harvest of every crop. This kind of field residues definitely will know when once we'll incorporate into the soil. It maintains the soil health by protecting erosion and conserves the water and enhancing the water retention and contributing for some soil organic carbon and nutrient recycling. So, but another kind of residues also available with this nowadays, that is processed residues. So these are the residues generally available after the post-harvest processing. So like husks and some crops, bagasse from sugarcane crops, molasses, and also shells from groundnut crop like that. So these residues compared to the field residues, we can see it is very easy to collect and have high potential. And so because globally, generally, not only globally, and in our country also, they are widely used for livestock feed, because 40% livestock population is there in our country. So they can be used as organic fertilizers and also particularly as a raw material for this biogas, bioenergy intensifications. So mostly they are useful for industrial applications. So generally in India, the bagasse, that is the huge quantity of bagasse obtained from sugarcane crop, is mainly used for cogeneration of electricity, that we'll know. And other oil seed cakes and husks also used for animal feed and compost material. So efficient utilization of these processes residues also, not only they will increases the economic value and also reduces the environmental burden, rather the open field burning. So coming to the actually crop residue management options in Indian conditions. So why the farmers are left with only two options for this crop residue management? Nowadays, we are the very this kind of residue burning. So this is the major issue. Almost from a decade we are listening, the farmers are used to burn their residues immediately after harvest of the rice or wheat crop or whatever the crop. So because this residue burning remains is a widespread practice among the farmers. So you can see the open field burning of 1 ton of stubble almost losses the nutrients approximately 5.5 kg of nitrogen, that is major nutrients like nitrogen, phosphorus, and potassium also. And not only this, they will emit large quantities of this methane gas emissions, that is carbon dioxide, methane, and nitrous oxides. So what made the farmers, what are the major causes for this residue burning? So we can see that nowadays there is a lot of usage of combine harvesters for harvesting the crops. So these availability of and use of combine harvesters, they have left the very loose straw on the field. The farmers are unable to collect that kind of huge quantity of the residue, and also the very short turnaround time between the two successive crops. So generally the farmer, they will cultivate rice in the Kharif. Immediately after harvest of the crops, he used to take the Rabi crops. So there is a very less time gap between the two successive crop cycles also. One of the reason So he is unable to collect or incorporate this kind of material. Even though this straw also, another one is high CN, due to high CN ratio, the decomposition is another major problem. Even though he has incorporated, there is due to less time, the incorporation process, the decomposition rates will be delayed. So that is also one of the reason, and also lack of affordable, efficient residue management equipments. So nowadays, there is availability of happy seeders, and also some roto mulchers are available for residue incorporation of paddy straw. But it is not affordable by some of the small and marginal farmers, because due to lack of some custom hiring centers in different villages level, so they are unable to afford this kind of residue management equipment is also one of the reason. And farmers' perception generally, residue is he is considering it as a waste material and rather than a resource, because, and not only that, he is having some myth that these residues will harbor some kind of pest and disease modules. That's why, so it is also, he wants to burn the residue that will reduce the pest and disease load. So this kind of causes major the farmer is taking up this residue burning. So residue burning not only leads nutrient deficiency, but also it will causes some environmental pollution also. Here you can see the state-wise trends in crop residue burning instance from 2020 to 25. We can see the Punjab almost in 2020, almost 83,000 incidents were noticed, but we can happy to share that this consistent downward trends indicate the positive impact of this intensified enforcement, because introduction of large scale deployment of crop residue management machinery. So this type of crop residue burnings are considerably reduced by 2025. That is almost 96% of the residues burning is reduced by 2025. So in both Punjab and Haryana, but in some of the states like Delhi and Rajasthan, still there is localized strategies has to be adapted to reduce these type of crop burnings. So coming to the second category, that is so recycling and product utilization. So another kind of in terms of majorly after crop burning. So second option we have to choose is the recycling and product utilization. So mostly in terms of soil health and conservation, definitely we have to motivate the farmers to retain at least 30% of the residues on soil surface. So which is mainly is a cornerstone of conservation agriculture. So next one is the bioenergy production. So we all know 1 ton of paddy straw, when you can yield up 3,000 meters cubes of biogas. Similarly, in cotton stalks and PGNP stems and sugarcane bagasse, nowadays they are converted to some briquettes or bio oil or bioethanol production also. And another product utilization mainly is animal feed. So nearly 50% of the residue in India are used as animal feed, and mostly in mixed farming systems. And not only this, it can also be used as some of the bedding material, especially in mushroom cultivation, which supports the rural livelihoods. And another, the biggest, this one usage of this product utilization we can consider is industrial applications. So these residues, so is a valuable raw materials for paper and pulp industries and briquetting and particle board production. So, and majorly the biodegradable mulching sheets. So coming to the, you can see the comparative assessment of crop residue practices under Indian conditions. We have some different kind of options are there for farmers. So you can see the open field burning. When he used this option, the major practices he used is quick disposal of straw between the two crop cycles. The key benefits is saves time and labor. But here we can clearly see the what are the challenges and limitations. It will severe air pollution and nutrient loss, and greenhouse gas emissions will be increased. Whereas when he wants to incorporate or it is used as a mulching, so mixing residues into soil surface or mulching improves the, no doubt, soil organic matter and enhance fertility, reduces erosion, but requires suitable time and suitable machinery for this kind of incorporation. And the third one is nowadays there is a pressure on synthetic fertilizers also. So definitely the farmer has to use the composting or vermicomposting or whatever the available organic manures. So he can use residue this kind for composting or vermicomposting also. So it will major practices, it will converts the biological conversion into organic factor. So definitely it will the nutrient rich compost and supports organic farming. But this kind of management option, it will time consuming and management is somewhat time taking. And other one is bioenergy production. So you can this one is requires a huge capital investment and decentralized this one. So and another one is animal feed also, limited cereals only will suitable for animal feed. All kind of crop will not be suitable for this kind of animal feeds. So industrial application is also another option for this crop residue management. However, the collection and the transportation logistics also is a challenges and limitation for this this kind of management options. So what are the different approaches at this juncture we can use for this crop residue? First of all is the crop diversification, because particularly where this rice burning is the majorly we come across with the rice fields. So rice area where huge area is irrigated areas, we come across with this kind of burning. Hence here we have to promote the crop diversification with this shifting part of the rice area to other alternative crops like maize and this one, and which is mostly will curb the residue burning practices. Not only this, once we promote the any kind of other crop suitable crops under crop diversification, we have to see the market and economic incentives also. So then only this crop diversification will definitely act as a good approach for crop residue management. And second one is nowadays there is a very high yielding rice varieties. So we have to through breeding techniques develop high yielding rice varieties with higher harvest index. That means to reduce the straw load also is one of the best opportunity for this reduce the burning of rice crop. And second one is mechanization and technological innovations. As we all know, nowadays very advanced agricultural mechanization equipment is available for this residue management, like happy seeder and improved rotavators, super management system meters and straw choppers also available. So which with we can use for a direct seeding without any need for burning. And third one is the by microbial interventions, as our earlier speaker is also so this mostly he has told the importance of this microbial activity with the different kind of farming systems and cropping systems. So here microbial decomposers nowadays consortia is available in some kind of bacteria with fungi. So they can be used as a eco-friendly approach to speed up the residue decomposition, which enhances the nutrient recycling. And besides this, bioenergy development and industrial utilization also we have to think of. So because this bio establishment of some bio power plants, biogas units or distilleries also, so we some kind of economic value, create some economic value with this agricultural byproducts. And at the most with all these policy support and economic incentives also is the plays a great role. So nowadays, this national policy for management of residues and emphasizes the discouraging this kind of residue burning. So mostly they will providing the financial incentives for this equipments on subsidies, and also awareness drives also they are conducting. With this also the residue management has become a very climate smart agriculture, and also it's go with carbon credit programs also. And the last not the least, the awareness and capacity building and community engagement programs with farmers. So farmer ultimately he is the end user. He has to motivate with this kind of capacity building programs on residue management, and some behavioral changes from the farmers as play a very long role and long term success. And here we can clearly see now last 24-25, this Punjab and Haryana and UP also, this CRM machines, that's crop residue machines also. So in a big way, they are provided with and also custom hiring centers. This is one of the good approach for sustaining this crop residue management activity. And we are also clearly we can see this strengthened agriculture mechanization, how it has reduced the this crop burning situations. Almost in 2021, the burning is almost only we can see the 10%, but now it is almost 86% of the people have having awareness to stop the burning in across the states. So coming to the another approach is crop residue management, not only to increase the soil health and environmental protection. Nowadays, this residue management with carbon credits is also one of the biggest this one, because with the addition of biochar or residue retention or some of the regenerative agricultural practices holds considerable promise for increasing the soil organic stocks, carbon stocks. So with this open field burning, when we will stop the open field burning, will naturally fostering the carbon sequestration in soil. As we all know, so carbon credit corresponds 1 metric ton of carbon dioxide removed from the atmosphere and other greenhouse gases also. So nowadays in India, there is a very limited number of private organizations. They're coming forward to venture this kind of voluntary carbon credit, this one. And in future also on this acquire the carbon credits from farmers who are implementing this kind of regenerative agricultural practices is one of the best method to foster the this curbing the open burning and fostering the carbon sequestrations. So coming to the advancing this crop residue management with climate resilient farming systems. So now we are generally will see the what kind of machinery is available, what type of the farmers are doing. But nowadays this kind of crop residue management should link with conservation agriculture. So because in almost green revolution has increased food grain in 4-fold with the high yielding varieties and as well as the very extensive tillage is automatically degradation of natural resources, but and also some of the problems like this El Nino effect, that erratic rainfall distribution, also delayed planting and increased erosion, high labor consumption and energy requirement is also so causes. So we have to definitely go with this type of conservation agriculture and also the crop residue management. So this concept all you well aware, this concept of conservation agriculture. So mostly already AK Singh sir has told the main principles is with the conservation agriculture is the minimum soil disturbance, mainly to erosion control and building the soil carbon, and with the soil organic cover with the diversified crop rotations, and also strategic nutrient application is also nowadays is one of the main option for this conservation agriculture. So what are the main key conservation practices? We can know direct sowing techniques. Nowadays, not only in paddy, in a traditional method, they are used to cultivate the paddy with puddling method and traditional transplanting method. But now the concept has changed. The direct seeding with puddled as well as the dry seeding techniques in paddy is also evolved, followed by the no-tillage systems of rice maize and rice wheat systems with the very minimum tillage operations. And the farmers is also nowadays getting some awareness, strictly not burning the crop residues, and also maintenance of permanent cover for weed as a residue mulch. The first one is the minimum mechanical soil disturbance. We all know these are some of the key methods and approach. So that is no tillage. This is mainly completely undisturbed soil conditions. The seeds are directly sown with specialized equipment. Our direct seeding is also one of the method involves by using specialized equipment to insert the seeds directly into the soil. And the second one, the third one is the reduced or minimum tillage approach. Also, this kind of approach is also with less disturbance. That means the soil cover will intact maintain, and the soil organic matter will also slowly build up in this kind of zero tillage conditions. And this specialized equipment, zero till planters and pneumatic planters nowadays available for this kind of sowing methods under zero tillage conditions. So these are some of the equipment which are available with farmers, but this kind they are not available. They are affordable. So hence custom hiring center has to be promoted with all the states. Then only the farmers is able to use this kind of machinery. And second one is also, this is a permanent soil organic carbon. So we can use these principles for erosion control, moisture retention, and biodiversity, especially for weed suppression. The third one is it's already told, the diversified crop rotations. So majorly, so these are the for pest and disease control, soil structure improvement, as well as the enhanced biodiversity, and also for the nutrient management. So especially inclusion of legume crops will fix the nitrogen in the soil and reduces the load of synthetic fertilizers in the subsequent crops. So fertilizer management, as you all know, so precision fertilizer management is nowadays is this one. So you can use the seed cum fertilizer drills for applying these fertilizers. And to optimize the nutrient use, this 4R principle is also one of the best strategy for this conservation agriculture. So you have to select the right source with and applying the nutrients in based on the need of the crop stage, with soil test based analysis. And also the placement is also one of the important depending upon the soil type. And not only this, the integrated nutrient management is nowadays is the this one. So without any organic source, the single synthetic fertilizer in coming days is not good for our soil health and self-sustaining the nutrients. Hence, you have to invariably use both this kind of crop residues or else organic manures combinedly with mineral fertilizers will sustain the yield levels as well as this nutrient cycle. And also depending on the soil conditions, also the split application of the fertilizer is also one of the important measurement. So they will supply the plants and utilize the nutrients efficiently. Not only this, they will prevent the groundwater contamination also. So this is a general this residue management in maize. Why we have to see the maize crop? Because so this is a very high biomass producer crop. And not only this, compared to the other crops, nowadays it is the rising ethanol production and impact on sugar availability. That is a climate resilient varieties are available and with a high yield potential with maize. And it is a crop with less water and environmental footprint as a byproduct for feed industry. Hence, definitely we have to look this maize crop for this better residue management practices. So these are the general key management techniques for maize stover, surface mulching or soil incorporation, or other alternative and commercial uses also. So we can use this as a biochar production and bioenergy generation also. So these are some of the machineries available with this maize shredders and rotavators, and pneumatic planter and happy seeders are some of the advanced equipment with this maize conservation agriculture under this crop residue management aspect. So these are some of the benefits of crop residue management. So based on these so addressing various multifaceted challenges, so what are the future strategies for this residue management we can see? So it requires definitely integrated interventions, that is combining policy intensives, technological innovations, and behavioral change of the farmer. Then only so we can address this issue in future. And not only this, definitely if the farmer has to adapt this kind of crop residue management with high advanced machinery. Promotion of custom hiring centers is definitely needed our, and trainings through farmer field schools by utilizing the extension units like KVKs, SEUs, and ICR institutes as the platforms. This is the one of the major this one to motivate the farmer, and subsidies for this residue based bioenergy units. Public awareness campaigns also enhance the adoption. So not only this, so we have to conduct the region specific research for low cost decomposition or decomposers, this decomposition accelerators, because so almost all the cereal crops are high lignin content and CN ratio. Definitely we have to use this low cost decomposers for accelerating this residue decomposition. And pest management, and because various multi-crop situations are across the country, definitely we have to look forward the better farming systems and better cropping systems to decrease the pest load and pest management under this residue retained systems through crop diversification. So last but not least, socio-economics of residue utilization is a vital to ensure the sustainable residue management in tropical agriculture. So thank you very much. I greatly acknowledge my sincere gratitude to the organizers of IIMR Ludhiana for providing me the opportunity to share little knowledge in this 21-day online training program. Thank you, Anand.
Thank you so much, ma'am. If anyone has a question, you can ask madam. You can ask madam. किसी का अगर सवाल है कोई चैट में कुछ क्वेश्चन है if not, thank you so much, ma'am, for covering extensively and for presenting in a nice way. And we have shared all your experience and the policies and other all aspects we have covered, madam. And thank you, madam. And someone is like also commenting that thank you, madam, nicely covered the topic. Thank you so much, ma'am.
Thank you, sir. Thank you very much.
Okay. So we have a third lecture. Kailash.
Yeah, I'm there.
Oh, thank you. Let me introduce our next distinguished speaker, Dr. Kailash Prajapat. He's a senior scientist agronomy, and he is currently posted at ICAR Central Soil Salinity Research Institute, Karnal. So Dr. Prajapat is a distinguished agronomist who's for research work focused on conservation agriculture, sustainable cropping system, crop residue management, nutrient management, and resource efficient farming practices. So he will cover the topic on surplus crop residue generation in Indian agriculture. The lecture will provide some valuable insight into crop residue generations and its efficient management and its role in supporting sustainable agriculture production. So with this introduction, I warmly invite Dr. Kailash Prajapat to deliver his lecture. Sir, the floor is yours.
Thank you. Thank you very much for nice introduction. Let me share my screen. Is my presentation is shared?
Yes, sir. Yes, sir.
Is it in full presentation mode?
Yes, sir.
Okay, thank you. Thank you so much. So, respect organizers, all the distinguished participants of this training program from different KVKs, universities, ICR institutes, as well as from the corporate sectors. A very good evening to all of you. So, the topic given to me is surplus residue generation in Indian agriculture and its management through conservation agriculture. So, a lot of things have already been covered by Dr. A.K. Singh sir and Dr. Srilata madam. So, lot of things already covered, and I will try to add some text to these informations because almost all the topic has been covered, and I think the glass is full now from the conservation agriculture knowledge. But I will try my best to add some test by adding some new information. So first, we should congratulate all the agriculture fraternities for, as we have now got the record production of food grains to 376 million tons this year. So we should congratulate all of us. At the beginning, it is all made through the technology-driven agriculture, enhanced irrigation and resource management, enabling policy support from the government, as well as our ICR system, resilient and progressive farmers, of course, and favorable monsoon also. And we, up to now, we are able to keep this pace, the food grain production, up to the level of population growth, and even we are maintaining the more food grain production than our population growth. But in the coming years, in coming decades, we would be required more food grain production. For that, we have to again keep pace the increasing food grain production. But most of the agriculture system have already been saturated. Our yields are now going to be stagnant. So how to deal with these problems and the issues in agriculture with sustainability? What are the issues that are affecting the sustainability of our agriculture system? Of course, low soil organic matter. Our both these speakers have already told. Soil erosion, multi-nutrient deficiencies occurring in almost every part of the India, and soil salinization. Another problems, the intensive tillage, which is declining the soil organic matter, destroying the soil structure, water and erosion in many parts of the country, reduced water infiltration rates, and sometimes waterlogging, sometimes the drought and water stress conditions in the soils, surface sealing and crusting due to the more and more tillage operations and soil compactions, insufficient return of organic matter to our agriculture crops, because organic matter is the main, which is a source of all the nutrients to the agriculture. And monocropping, of course, we are now practicing intensive agriculture and not diversification, and forgot about the legumes in the systems. And the climate change now become reality, which is adding to our deteriorating agriculture sustainability, decreasing availability of labor in some part of the country, decreasing water supply for agriculture. Of course, we are now next revolution will be for water. So agriculture is the mostly consuming the 80% of our groundwater. Imbalance use of inorganic fertilizers. We are depending mainly on the inorganic fertilizers and forgetting about any organic source. And if we see our organic carbon content in the most of our agroclimatic zone is almost below 0.5, and in some parts of the country like in Punjab and Haryana, it is around 0.3 only. Then why carbon is so important? So if we talk about the sustainability, it gives all part of sustainability to agriculture. It is key to improve the crop productivity or sustainability in the agriculture. In environmental terms, it is also cause of pollution if it is emitted in the environment. If it's sequestered, it's solution to the pollution also. It gives resilience to climate change, and it is also source of energy for all the plants as well as human beings. Then all nutrient cycling, whatever nutrient cycling is occurring in our soil system because of the carbon only. Because even we are applying fertilizers, its availability in terms of available nutrients depends on the soil organic carbon mineralizations. Then how management practices are affecting our organic carbon in the soils. So in the beginning of our intensive agriculture, our organic carbon content in soil is almost at a good level. Then we started this intensive cultivation to feed our ever-increasing population. Then we are only taking out the organic carbon continuously decline. And if we are not going to adopt any offsetting practices, then it continues to decline. But if we start the offsetting practices through any practice which is giving carbon to the soils, then it again will keep to increase. So it is very important to maintain the organic carbon in our soil. So what are the practices for restoring the organic carbon or soil health? We talk about the integration of organic manures, but organic manures are very short in supply. If we want to apply in our agriculture systems, integration of legumes in cropping system, of course, it improves the soil fertility by sequestering the nitrogen, as well as its deeper root systems. It recycles the nutrients also, and crop residue recycling to soil is also one important aspect to restore the soil health. Then residue generation from the agriculture, Madam has also discussed that we are almost producing more than 700 million tons of crop residue from the different crops, and major crops are rice, wheat, and sugar canes, then maize. These are the major crops which are giving more residue generation, because it depends on the production. More the production, more the residue generations. And rice contributing 23%, wheat 24%, sugarcane 23%, and maize is also contributing to 6 to 8% to residue generations. And where it is generated, of course, where we are producing more to these crops, Uttar Pradesh, Maharashtra, Madhya Pradesh, these are the states we are majorly producing the crop residues. Then Rajasthan, Punjab, Haryana, and Gujarat. These are the states which are producing more amount of crop residue. But all crop residue, whatever crop residue we producing, it cannot be used for the soil recycling, because the crop residue is also being major source of fodder in our country. So we cannot say that all crop residue should be recycled in the agriculture. But what is the quantity of surplus crop residue which is not being used by the farmers, by fodder or any purpose, and it is either left out somewhere or sold or some burned in most of some part of the country. So it is estimated how much crop residue is surplus or how much crop residue is being produced in our country is estimated by the residue to crop ratio of the crops. How much yield it is giving, and how much ratio of the residue in particular crop which is used combined with the dry matter composition of the residue, it is used to estimate the crop residue generation. And then surplus crop residue is estimated how much proportion of that crop residue produced is not used for any other purpose and either left or in the fields or whether burned. So depending on the different states used, depending on the crops, in our country, it is estimated that around 141 million tons of crop residue is surplus, which is not being used by the farmers themselves. So that can be used for recycling or any other purpose. And other estimates, there are any estimates by many scientists or many other state functionaries. They show that around 150 to 200 million tons of crop residue is surplus in agriculture, and that surplus residue can be used. So one of the use is burning, because burning is very easy. So mostly maize, rice, sugarcane, wheat residue is burned. And if we see the proportion, 48 to 50% of the rice residue is burned, 20% of the maize residue is burned, and 24% of the wheat residue which is burned. Then why farmers are burning this crop residue, particularly in the Uttar Pradesh, Punjab, and Haryana? It is not like that the farmers are burning crop residue without any reason. There is certain reason. Because in the paddy and wheat cropping systems, there is, after harvesting of the paddy, very little window is there. 15 to 20 days of window is remaining with the farmers to prepare the field and to sow the wheat crops. And if wheat crop is delayed for the sowings, there is yield penalty in wheat due to the terminal heat stress in the February March. So, secondly, the mechanization in this part. More than 80% of area is being harvested by the combine. Sometimes we introduce one solution and it creates another solution, the combine harvesting, which leave the crop residue in the windrows in the fields not evenly distributed. So how farmer manage? How can it cannot field cannot be tilled if residue is left over as a windows? So they think the burning is the only options. And the other users of crop residue is giving very low economics. So farmers burn the crop residue. Then what are the other practices that can be used to manage the crop residue? One is the composting. It is very good to composting is purpose of the nutrient supplying, purpose of the soil application, but it also requires some infrastructure, some technology to take the residue out, then preparing the composting, then again applying in the field like the biochar. Residue removal or bending, it is also being practiced, but it's laborious and also leads to removal of residue. And sometimes the whatever balers are prepared and removed out of the fields. But after some times, these are used in pre-cleans, means the residue which is taken out of the fields but burned in another way. It is burned in another way. So it is not stopping the burning. Residue burning, very easy for the farmers. Residue incorporation in the soil through the machineries, very good options. Direct drilling under the residues like conservation agriculture and bioenergy production also it can be used. So if it is retained on the soils, so if we consider that the average nutrient content of the crop residue and whatever surplus residue is retained in the soil, it can give up to 8 million tons of nutrients to the soil's back. If you consider 140 million tons, if it is 180 million tons, it can give 10 million tons of NPK in terms of fertilizers. So our agriculture is in the deficit of 8 to 10 tons of nutrients. So we can bridge that gap by returning to the soil. Another uses of crop residue are biochar formations. If all crop residue are used, surplus crop residue is used for the biochar formation, it can give 34.5 million tons of biochar, and which can reduce the global warming potential by carbon sequestration to the tune of 400 million tons of CO2 equivalent. So it can also give the carbon credits. Then it can also be used for power generation. If the old surplus crop residue is used for the power generation, it can generate 18,000 megawatt of the electricity. Then biofuel or bioethanol production, if all the surplus crop residue is used for the biofuel production, it can produce 51 million million liters of the ethanol. And government is also promoting the circular agriculture by recycling of all the waste material or agriculture waste. Like Govardhan scheme, it is promoting the biogas production or compressed biogas production, and more than around 1,000 units has already been installed in different parts of the country, and it is being promoted with the MSME. And any group can go through MSME for this Govardhan scheme and can register online and can go for the CBG productions. Then animal husbandry management, animal husbandry waste management through the Animal Husbandry Infrastructure Development Fund. Then Agriculture Infrastructure Development Fund is also being promoted to manage the agriculture waste and crop residue management. Custom hiring centers for the heavy machinery like heavy seeder. Each farmer cannot go for the purchase of this kind of heavy machineries that are costly. So custom hiring can be promoted through the custom hiring centers, and more than 42,000 custom hiring centers has already opened by the government support, and many around 4 crore thousand subsidy has been released for purchase of these machineries. So these are the options where government is promoting the circular agriculture through waste management. Then in situ management of crop residue is very beneficial for the agriculture. If it is managed in the field, that is the best. So how it can be managed? It can benefit the agronomic benefits given by enhancing the productivity, enhancing the organic matter, soil water conservation by binding the soil particles and improving the soil structure. And secondly, the environment, indirectly reducing the soil erosion, improving the water quality by reducing the leaching of the nutrients to the ground water, improving the air quality because of the mulching and everything. This reduces the agrochemicals use. Biodiversity increase due to the management of microclimate and carbon sequestration in the soil and agriculture systems. So how the residue can be managed through conservation agriculture or climate smart agriculture or regenerative agriculture. Now at present we are talking of the regenerative agriculture, because conservation agriculture is maintains the sustainability. Regenerative agriculture enhance the already degraded systems, enhance the soil quality which is already degraded. So residue management and conservation agriculture principles fully accompanies the residue management and food security, as well as the regenerative agriculture principles on climate smart agriculture. So at our institute, we have very big experiment going since 2009 on a very big plot. Sometimes it is said that scientists conduct research on a very small area and they extrapolate the findings. So how farmers can adopt it. So each plot is having 2,000 meter square area, and we are having different scenarios in this. So scenario one is the farmer practices conventional rice wheat cropping systems. Scenario second is improved, like rice wheat mung bean cropping systems with the rice transplanted with wheat cropping with zero tillage and full rice residue. Then third scenario, we are going with complete zero tillage, means no tillage in Kharif, Rabi as well as the summer season. And fourth scenario is alternative systems. So this training is mainly based on the maize, how maize is growing. So maize wheat mung bean system is an alternative to rice wheat cropping system with full conservation agriculture. Then precision agriculture and precision water management is also coming. So we introduce the precision water management through subsurface drip irrigation in rice wheat mung bean and maize wheat mung bean cropping systems. So since 2009, we are returning the crop residue in the scenario 2 to 6, and up to now, more than 200 tons of the residue has been recycled in the soils. So sometimes they say that too much of residue recycling creates so much problems, but up to now, as of now, we are not facing any problems, and this much of residue has been recycled. This is the maize residue. Wheat is being sown in the maize residue with the help of the happy seeder, and this is the wheat sowing in the rice residue with the help of the eco seeder. This is the rice wheat mung bean systems. Rice is sown with zero tillage in the completely mung bean residue. Then wheat is sown in the 100% rice residue, and mung bean introduced in the summer to restore the sustainability of the systems. And this machineries enable the sowing of the crops in the residue. This is the combined harvester with superstar management systems. This superstar management system spreads the residue equally in the windrow, so that the sowing can be done easily. It is same day we can harvest the rice, and the residual moisture we can sow the wheat in the residual moisture in the 100% of the rice residue. And in drip irrigation, it is not possible for sulfate drip irrigation to work in conservation agriculture, because we have to do sowing on the soils, and farmers have to again dismantle the drip irrigation lines, and then again have to lie on the surface to get rid of these problems. And conservation agriculture we are not following any tillage operation. We installed the subsurface drip irrigations below 20 centimeter in the soil in the root zone, and we are giving irrigation as well as the nitrogen fertigation through subsurface drip irrigation, and we reduce the nitrogen application to 20%. So this is maize with mung bean systems, maize with flooding systems, as well as the subsurface drip irrigation systems. And VPC, due to this residue retention, because conservation agriculture alone or zero tillage alone not have very much benefits until it is accompanied or it is laid with the residue retention. So soil bulk density, soil compaction is reduced drastically. Organic carbon stock in 10 years almost double from the business as usual systems. Then the infiltration rate. Sometimes the rice fields creates a waterlogging, and maize is not performed where waterlogging is there. But due to the continuous practicing this conservation agriculture, water infiltration or cumulative infiltration increased more than 10 times. So there is no problem of this waterlogging, and subsurface compaction due to the tillage operation also reduced in the CF loads. This is long-term productivity and sustainability. Long-term productivity is highest in the maize wheat mung bean system with subsurface drip irrigation systems. This is also system productivity. Then we also analyze the sustainability. The sustainability as well as the equivalence, which gives the stability, is whether the productivity is stable or over the years. But so these are also very sustainable as well as stable in the CA plus maize wheat mung bean and CA plus rice wheat mung bean system. CA with flood irrigation is sometimes depends on the monsoon seasons. If monsoon is good, the dye-seeded rice performs better, but monsoon not good, sometimes it has problems. Irrigation water is not dependent totally on the residue, but due to the combined effect of conservation agriculture and this residue retention, the water saving is also there. And greatest water saving is with the maize. Only 70 to 80 mm of water is required in drip irrigation systems, as compared to more than 17 or 1600 mm used in the rice. This is parcel factor protective nutrients. When soil is improved, nutrient parcel factor productivity or the nutrient use efficiency also increases its own. Energy use also reduced, and one of the greatest problem in the wheat in this region is Felleri's minor problems. So after 4 or 5 years of conservation agriculture practices, the drastic reduction in Felleri's minor population was there. Now we are not applying any herbicide to control the Felleri's minor in the wheat. Then earthworm population, due to no disturbance, retention of the soil, earthworm population increased dramatically and more than 10 times, or it is not seen in conventional plots, but it is very much visible in the rainy seasons. We can see walking here in the plot surface in the CA plots where residue is retained. Then climate change is also very much talked in this region. So this CA practices also drastically reduce the CO2 equivalents from the agriculture systems, as well as the carbon footprints through sequestration of more and more carbon. Then a large scale studies have also been done in Punjab and Haryana, and Effect of residue, if we see the residue retention to different, whether full residue or partial residue to 5 to 20 tons per hectare, it significantly improved the yield of wheat in this Punjab and Haryana region. In other experiments where food conservation agriculture cannot be followed, we are following the partial conservation agriculture where 1/3 crop residue only retained in the soil. In the arid and semi-arid region, where the residue also used for the fodder purpose, so 1/3 retention of crop residue with following the DSR and wheat is also giving advantage in terms of carbon retention in the soils, as well as the improvement of soil physical properties, improvement of soil quality, and sustainability also. So this is how this CA plus residue management giving the resilience. This is the plots where residue is burnt, wheat is showing terminal heat stress, but where residue is retained and CA is followed, there is no sign of the terminal heat stress, and other advantages also there. So at the end, through whatever details I have gone and whatever experiences are there in this region, we should promote the conservation agriculture practices where possible, either in complete or partially with residue retention. And in situ residue management should be promoted in place of the ex situ management for sustainability of our soil systems. And residue cycling can also be increased for soil health improvement, conservation moisture, enhancing nutrient availability, and increase the carbon sequestration. And there is need to provide the incentives for carbon residue retention in terms of the sequestration of carbon, in terms of the carbon credits to the farmers, those who are adopting the residue management practices. And the tenant farming in some parts of the country, the tenant farmers are not part of any subsidy. So they are not receiving subsidy, so they are not bothering about this residue management or other things. So they should also be brought in the subsidy programs and also incentivize programs, so that they should also manage the crop residues, also think about the soil health. And support evidence-based policies are required through the life assessment, because we have multiple options, biochar, ethanol, anything, these. There should be a proper life cycle assessment for overall countries required, where we should go, which practice, so that farmer may not get confused and they adopt whatever practice is recommended for particular region specific. With this, I thank to all the organizers for giving me this opportunity to share our experiences. Thank you very much.
थैंक यू सो मच सर. अगर किसी का सवाल है तो सर से दो क्वेश्चंस वी कैन टेक अप क्विक. एनीवन? किसी का?
ये शायद तीसरा लेक्चर था, लास्ट में रुकना बहुत मुश्किल होता है पार्टिसिपेंट्स के लिए.
तीसरा लेक्चर था सर, और कंजर्वेशन एग्रीकल्चर में ये शायद वो हो गया सर, ज्यादा हो गया. So no issue sir. So if there is no further questions sir, thank you very much sir for your excellent presentation sir, and you have shared your valuable research work also and practical experience with us, and your lecture was very informative sir, and I'm very sure that all the participants have learned a great deal from your insights sir. So once again sir, thank you so much sir for your nice presentation.
Thank you.
Thank you sir.